What's going on, everybody? And today I will be talking about mutability real quick, and the main difference between mutable and immutable objects is that one of them is able to be changed, whereas the other one, if you try and change it, you either have to create a new ID or object for the thing, or you can't change it at all. So we will be showing code for this as well to show examples. We will be using the ID function to see if the ID changes or not to determine whether it's mutable or immutable. Now I'm going to go through this very surface level. Remember, if you want to look more into this, I suggest you read side books or look at other videos. I'm just going to be showing you what is mutable and what is immutable so you can get some more points on the exam. So, I have a little word bank right here that went over stuff that you guys have learned. We have some data structures like lists, sets, tuples, named tuples, and dictionaries, as well as some types, which is strings and integers and floats. So, to begin, I want to give you two conditional statements or two rules to see if something is immutable or not. Number one, if it has tuple in the name, just automatically write it as immutable. And if that doesn't happen, then we have to check with our code to see if it's mutable or not. So first, with rule number one, we can see that we have tuples, which has tuple in the name, and NamedTuples, which also has tuple in the name. I don't care if it has a ._replace or anything like that. These are both immutable. So we're going to go ahead and write it right here. So it is immutable, meaning that we cannot change it without changing the ID or changing the entire object itself. So since that we have those knocked out, we can go ahead and cross them out. And next we will be showing some code example of this to show that if I do use the replace function for the name tuple, the ID will change. What's going on, guys? And I will now be first showing you only a tuple example here. So in this code right here, I created a tuple which is pointed by the variable called example, and I will be printing the element at index 0 is whatever it is, which it should be 1. So when we run this code, as you can see, I successfully outputted that the value at index 0 is 1, and I will be providing two examples for you for mutability. Example number 1 is that because tuples support indexing, we're going to try and replace the first element with 4, just like how you would with a list, and see if it works. Now, if this was mutable, it would allow us to do it, but as you can see when we run our code, we get a type error because tuples are immutable, so it does not support item assignment. For our next example, we will actually do something a little bit sneaky, and it'll look like we changed the code, or it'll look like we changed our tuple, but in reality, we did not. So let me put it at the end right here. I'll be printing the ID, then somehow appending our tuple, and let's see what happens. As you can see, it looks like we did append our tuple right down here. It looks like we added 4 to the end as we would in a list. However, if we use the ID function, as I've mentioned before on the whiteboard, you will see that the IDs are different numbers. If you look at the last 2 or 3, the last 3 digits, they are different, meaning that Python had to give us an entirely new object. If it was mutable, these numbers would be the same, but because they're not, then it's immutable. Alright, and next up is an example on NamedTuple. So in order to get a NamedTuple, you have to do from collections import NamedTuple. Here we have a simple NamedTuple called person, where our person is named Bane, which is me. It's not my real name, and I am 20 years old. And as you can see, I will be doing the ._replace example right here. So first, I will be printing what my age is, which it prints out 20, which is correct. After that, we're going to do the ._replace to do age equals 21. When we do that, it looks like it did it. I do turn 21 soon, so awesome. It looks like it worked. But however, if we print out the ID of our person, you will see that they are not the same. So let me just comment these out just so it's a little bit easier to see. And when I click this button, as you can see, we have clear differences in the end right here, as well as some other in the middle, displaying that this is not the same object that we had originally. Because the ID changed, it means Python had to create a whole new object for us, meaning it is immutable, and we were not allowed to change it, so Python basically just gave us a whole new person. Next up, we're going to move on to list. And because everything doesn't have a tuple in the name anymore, we are no longer going to use rule number 1, and we're going to have to use code to see whether it's mutable or not. So lists are actually mutable, meaning that we can add stuff to it, remove stuff to it, change a specific index. So we are going to go ahead and write list in the mutable category. So next up, we're going to go cross this out of our little word bank, and we're going to now show code example of list being mutable.
What's going on, everyone? And for this example, I have created a variable called example list, which is pointing to the list 1, 2, and 3. I will show you now. Once we print it, it says the element at 0 is 1. So I will be showing you 2 examples right here. One is the example where we tried doing it on the tuple, but instead we'll be doing it on the list to see if it works. And as you can see, when we do that, we successfully changed the first element from 1 to 4. Now that that example is over, I will now be showing you example number 2, which will show the ID method. In this example, we will be using the built-in function to append Bane Beetle on Roblox into the example list, and this should work, and the ID should be exactly the same. So when I press this play button right here, and as you can see, these two numbers are exactly the same because lists are mutable, whereas a tuple, the ID change, this one, it is exactly the same. And as you can see, we're able to put integers and strings into a list. So yeah, lists are mutable.
Next, we're going to move on to sets, which is very similar to list, except its main goal is to remove duplicates. You're able to add stuff to sets, remove stuff from sets. The only difference is that there are different built-in functions for it. It doesn't have an order, and it removes duplicates. So because we are able to modify a set without changing the ID, we're going to go ahead and put it in mutable category. Next, I will be showing you some code to demonstrate why sets are mutable.
Alright, so as you can see in this example, I created a test set right here with 1, 2, 3, and 1. I'm going to go ahead and show you that it removes the duplicate. So as you can see, it only prints out 1, 2, and 3 because 1 is a duplicate up here. Now that that's out of the way, I'll be showing you 2 examples where we print out the ID, add, and print out the ID again, and remove. And the ID should be exactly the same. So what we should see is the ID, the new set with a 6, and the ID should remain the same. And as you can see, our set has successfully updated. The numbers are exactly the same. You can do a top-down inspection. And if we do the same thing when we are removing a number, in this example, we are removing the number 2, we get a very similar result where the 2 has disappeared and it's only 1 and 3. And the IDs, if you do a top-down inspection again, they are exactly the same, showing that sets are indeed mutable.
Next, we're going to go talk about dictionaries. Ignore that black smudge. So, dictionaries are actually a little bit more complicated. They kind of come in 2 parts, and they kind of fill both of these roles. The key of a dictionary is not mutable, because imagine if you're trying to go to a McDonald's menu and there's 2 items that are listed exactly the same but different price. If we have 2 keys that are exactly the same, then Python won't know where to point it to be honest. So keys of a dictionaries have to be unique and immutable, whereas the value, they can change over time. The prices of food in a menu can change over time, so values there have to be able to go up or go down. So we're going to split dictionaries into 2 parts, which is the dictionary key and the dictionary values. And for the mutable side, a dictionary's values will be mutable, because for the value, you can put a list in there, you can put anything you want in there, you can change it from time to time, whereas the key, the dictionary key is immutable because you want them to always be unique. You don't want someone later down the line changing your dictionary key to be exactly the same one as another key in it. It would just be really confusing, and Python doesn't know how to handle that. So instead of learning how to handle that, it just prevents you from doing it in general. I will show you code example of this where I try and change the key as well as the value.
Alright, next up is dictionaries, and as you can see, I created a variable called testdict, and it is pointing at this dictionary with string as keys, and the burger is pointing to the integer 45. and random list is just pointing to a list. So our first example, we'll be actually overriding this dictionary and seeing what happens when we have two keys that are exactly the same. And as you can see, we only printed out one element. So instead of having two elements where Burger is pointing at 45 and the list, Python automatically gets the oldest one and overrides it. So 45 is now overwritten with the list right here, showing that we cannot have two keys that are exactly the same. Otherwise, one of them will be replaced. Example number 2, because the keys must be immutable, what happens when we try and put a mutable object like a list as the key? So running this example, I put the list as the key and the string as bruh. So let's see. Oh, sorry. The key as a list and the value as the string bruh. And as you can see, we get an error. We get a type error, which is unhashable type, which is list. Now, you'll be exploring what unhashable means in ICS 33, but long story short, it is mutable, so it is unhashable, whereas hashable objects are immutable/unique. So next up, we're going to try a new example. We're going to take our current dictionary, right? And we can do this, access the key, random list, and then dot append, let's do 6. And let's see if that runs in the first place. Key error random list. Yep, I forgot the capital L. Sorry guys. And this should work now. As you can see, we were able to run the program. And if I print out our dictionary, as you can see, our list or our dictionary was able to get updated, and I will print the ID of test dictionary before and after. So the first one that will appear will be before, and the one after will be what happens when we append it. And as you can see, these two numbers are exactly the same. You can go ahead and do a top-down bottom inspection of this. These two IDs are the same, showing that the values of the dictionaries can be mutable and we can change them over time. That's how we changed the list just now, whereas the keys have to be unique and immutable. So if you ever see this in an exam, be sure to elaborate why these guys are immutable and mutable, and why did Python make them this way.
Next up, we have strings in Python. Now, this is different than other languages. Python strings are immutable, whereas I know some other languages like C++, they may be mutable. So if you try and change the string by directly accessing it from an index and changing that index to another character, that's not going to work. So we're going to put strings in the immutable category right here, as you cannot change them. Do not mistake this for changing a variable and making it point at another string. Strings itself, you can't change it no matter what. And I will be showing you code example right about now.
Yeah, there it is. You can't change it.
Next up, we have integer and floats. So, it doesn't really make sense to try and change what they are. The easiest way I can show you this is if we just put it right here. They are immutable. And I will show you code example and it just won't work. So yeah, there you go.
Yeah, they're immutable. I don't know how to try and change an integer, to be honest, like the previous examples, but trust me, they're immutable.
And that is everything that is in the word bank and I wanted to cover. The reason why I made this video is to specifically target a little bit more points on the exams, because this I've seen some people call tuples mutable, where it should be the other way around. So that's why I emphasize if it has tuple in the name, go ahead and put it in immutable. And the rest of this, I will be showing you the code example as well. So just remember, this is a very, 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 very oversimplified version of all of this. There's definitely a lot more information on why things are immutable and mutable. If you want to look it up, there's plenty of good YouTube videos. You can read more of the side books, or you can ask one of the LAs or Professor Alfaro herself. So yeah, that's all from me, guys. Good luck out there.